Hello, gentlemen. Mr. Novak here. Request from a student to help him with equations, in particular ionic compound equations. And his first question was, how do we know what state they are in? Well, first of all, you most probably will be given the reactants. That's what we start with. And here's a simple example. Sodium carbonate is mixed with. So clearly, what we're saying is that, let me just get a pen, please. Um, let's see, mixed is mixed with so sodium carbonate mixed with calcium fluoride. But in both cases, they state them as being solutions. So that straight away informs us that they are in the aqueous state. So that's step one. Step two now is we need to go away and work out the chemical formulas for these two compounds. And you're not alone on this one. Remember on page 17, all right? Page 17, you have your valency table. And from your valency table, you will find the sodium Na1 plus, which is a cation, and the other one I think was the calcium 2 plus. They're the cations. And on the anion side, we have the fluoride, which is 1 minus, and the carbonate. Remember, carbonate is a polyatomic 2 minus. So let's go back to the equation. So we write those out in the combination, which is sodium 1 plus. We'll just write plus. By the way, it's little a, don't write capital A. I'm going to have to take marks off. The carbonate, remember, was 2 minus. Mixed, which means we put a plus, and calcium, Ca2 plus, and fluoride, 1 minus. Now, to make these equations, we need to do what's, if they're the same, one of each, but if they're different, which is in this case, we need to cross over. So the two crosses over, so we need two. So because that's a 1, we don't bother crossing over. Again, that's a 2 and that's a 1. They're different, so cross over. We need two fluorides. Don't worry about the 1. So we're now ready to write out the formulas for those two compounds. That is Na 2CO3. Now remember, it's aqueous. Give us the states, otherwise we'll lose the mark. And the calcium is calcium fluoride. Remember, we needed two fluorides for every calcium, and it's also aqueous. Sorry, aqueous. All right, now we're doing ionic compound mixtures, so it's going to be a classic double displacement. In other words, the sodium is going to take the switch places with the calcium. So we'll now have the calcium going with the carbonate. We've already done most of the work, so all we need to do now is write out the calcium with the carbonate, which remember calcium is 2 plus, and the carbonate, which is CO3, is 2 minus. And the sodium fluoride is 1 plus, and the fluoride 1 minus. Now, in both of these cases, the number's the same, so we just need one of each. That's CaCO3 and Na fluoride. The only thing we need to do now is decide if there was an actual fact chemical reaction, which could be the producing of a gas. Well, we clearly don't have any of those. We're going to obviously see if we have a precipitate. And for that, you need the precipitate table, which will be on page 23 of your booklet. So you'll need that for the test. And we're looking at sodium. Says sodium. No, actually, in fact, sodium never precipitates. Fluorides do occasionally. They're there, but certainly not with the sodium. So that stays in solution. While the other one was calcium, there's calcium, there's the carbonate, and yes, sure enough, it does in actual fact precipitate, which means it's a solid. So we use a simple S, do not use P, please. So going back to our equation, we have this is S for solid, and this stays aqueous. So you remember, you'll be 1 mark for that, and a couple of marks for the balance for the chemical formulas. But now we need to go and balance it because we remember it's conservation of mass. You can neither create nor destroy it. You have to have just a rearranging. So let's have a look. We always start with the carbonates. We've got one carbonate on this side, we've got one. That's great. We then maybe look at the sodium. We have two sodiums on this side, and we go across the near, we only got the one. So we need to make two sodium, but don't put a two there. You cannot change the formula, you can only put a big two. So we now have our two sodium, but we end up having two fluorides. So let's check if we've got our two fluorides. And sure enough, there's our two fluorides. So we fix those up. Got it, was single. Now we have to check one calcium, one calcium. So that is a completed full ionic balanced equation. The other one is, of course, the ionic. Now, with the ionic, we just want what was actually reacting. And of course, what was actually reacting was the calcium carbonate, which became chemically joined together to form a solid. What joined together? The cation Ca2 plus and the anion CO2 minus. And because we got the same numbers, we only need one of each. And don't forget, they were originally aqueous. There it is, there for the carbonate, there for the calcium. Oh, by the way, order is not important. Don't get caught up which is first, doesn't matter. And so that is complete. Remember, these show what actually the sodium and the fluoride were only spectators. So, and don't forget, you also might need on page 9 your periodic table. That's page 9. For instance, you might need it for, say, doing the oops, 2s1. Yeah, the configuration 1s1, 1s2. Notice that there'll be 2p6, 2p6, 2p, 3, 3p6, 4p6. Noble gases always end in p6. There you go. All right, have yourself a great night and prepare well for the tests coming. Cheers.